Dear Spark fans, welcome to another session, Data with Nick the Greek. Today we're gonna have another exciting topic, and we're gonna be talking again about Spark partitioning. So we already learned about repartitioning in the past, and so today we want to screw it up a little bit on purpose to really see how it works in the background and also see how you might have some surprises when you're configuring and using repartitioning. And maybe you still remember when we use repartitioning by columns in our previous episode before. We had some weird behavior. We had some skew in the partitions, but we had also some empty partitions. And that's something we really want to deep dive today. So today's agenda is basically we're gonna start a short recap into repartitioning, into the repartition function. And then we're gonna deep dive into the round robin hash partitioning and range partitioning. So that's a function which we haven't had a look today and really see how it behaves. Before we start, let's have a look on our sample data set, which we usually use for doing an analysis. So we have a very simple data set, in this case only with 10 rows. And for partitions, we have a continuous ID as an integer and the same thing as a string. And then to generate some more skew in the data itself, so let's do it with 20 rows just to make it visible. We also take like the first uh, string value of the number and the last value of the number as a string available. All right, repartitioning. So what we learned before already is repartition you can use to increase or decrease the number of partitions. So with coalesce, you can't do it. But one disadvantage is you have a shuffling, and that's something really important because it's a more heavy execution which you're doing. Um, if you repartition without mentioning a column, so you have two options, you can define a column. Then we're talking about hash partitioning. If you don't define a column, it's a round robin partitioning where we're going to have a look in a bit. And it creates quite uniformly distributions. Instead, you can use a column as mentioned, and then you use the hash partitioning. And important is also if you don't define a number of partitions, so you're gonna take the default for Spark SQL shuffle partitions, which is 200, and this is gonna be also later more important when we're gonna talk about wide transformations where we have also shuffling included. And just to have a quick look on the documentation, so how you use repartitioning, that's a function, so you can set the number of partitions, and additionally you can provide one or multiple columns where you can do the repartitioning. And here you can see a few examples. So now as we already learned and know how repartitioning is working, let's deep dive into the first repartition strategy and how it works. So round robin partitioning means we basically go row by row and assign each row after each other to one partition. So let's assume we want 4 target partitions. So we define the target partitions and we um, oh man. Okay, so let's jump into round robin partitioning as a first strategy. So what we of course have to do is we have to define our target number of partitions. So let's assume, for instance, we have 4 partitions as a target. So now let's say we have a data frame which is 10 partitions. What's basically happening is per source partition, we're going round robin, row by row, and assign each row to one partition after each other. So let's say we randomly start, so it's happening randomly. So when we start with partition number 1, then we go like row number 1 has partition 1, row number 2 has partition 2, row number 3 has partition 3, and the first partition ID is always 0. So after 3 goes with 0. And how do you screw it up? So one simple example is we want to partition, we have less rows than target partitions. So you can imagine, okay, if each partition has 4 rows and we have 5 target partitions, for instance, and how should you reach a 5th partition? And it can happen that some of those partitions then gonna be empty. And let's have a look into a data set. So here we generated a data set with 10 partitions and 20 rows. That's what the function does. And what we can see here is an aggregated table. So basically the number of rows per partition. So you can see, okay, we have all our 10 partitions and each of them has 2 rows. And well, 10% of the data uniformly distributed. Now, what we're doing is we repartition to generate 5 partitions. And I mean, what do you assume? You have 20 rows, you want to repartition by 20, you assume that every partition gonna have 4 rows. So, and you guess it already, we screwed it up a little bit here. So we can see that we have some skew or distribution here. And why did it happen like that? So let's have a look on our data set again. So that's the partitions which we had before, so uniformly defined. And when we're jumping and see which partition has been assigned here, we can already observe how round robin work. We're gonna have a second example in a bit. So we have here the first partition, and what happens here is it probably started with the ID 4, because our target partitioning is 5 here. So we have 0 to 4, and then the next partition ID is 0. So here randomly came again with 4. So it's the next one is 0, and that means by that it somehow skipped some of the partitions. And this usually happens as said, like if your number of partitions you want to target is higher than the number of rows per partition. This of course usually only happens in very small data sets. But also if your data set is not dividable by the number of partitions you want to achieve, and you have like some kind of rest, you're gonna have like a slight skew in the number of partitions. And let's have a look into another example. So now let's say we have 5 partitions. That means every partition has 5 rows. Or let's do it the other way around. Let's say here we have each 5 rows, and now we're gonna do repartition 5. So now let's see what's happening. Okay, here it works. And why did it work? So let's have a look, because every of the partitions have 5 rows. So it just starts, wherever it starts, it's gonna end up with all the partitions. But if we're gonna do now, let's say, a repartition to 10, we're gonna see that we have some kind of skew again. And so of course we would have assumed, okay, we have 10 partitions, everyone gets 2 rows as our initial data set. But what happens is, so first partition, so it seems like it started at 9 and then 0, 1, 2, 3. Then 12, second partition. It started at 4, 5, 6, 7, 8. No more space to assign the other any other rows to the other remaining 5 partitions. Same game. Here it started at 9, 0, 1, 2, 3. Same again. Here it started at 8, 8, 9, 0, 1, 2. And that's that's what happened here. So usually how you can get rid of the problem is you just increase your data set a little bit, and in this case we managed to have like an equal size of partitions. I also mentioned before that well, if it's not dividable by 10 in this case, you might have some light skew. That's what you can see here. Of course, in this case, it couldn't be repartitioned properly. So one row had to go into the next round of repartitioning, most probably here, because 2000 by 10 is dividable, and then a little bit and then you have one row additionally. That's why we have slight skew, but that's in round robin. You usually cannot do much wrong to screw it up. Now let's come to hash partitioning. So as hash partitioning already says, there is some hash value involved. And what we basically do is in hash partitioning, you partition based on a column. So you not only define the target number of partitions you want, but also the column you want to partition. And what's basically happening here is Spark is hashing with a hash key which is called momo3 each value. So basically, outcome is a number. And what's happening here afterwards is we create the modulo based on the number of target partitions. So if you want to achieve 5 partitions, we have like a number 1000. We do modulo 5. So 1000 modulo 5 is 0. And then we might have 1002. Then modulo 5 is 2, for instance. So it would be the partition, the third partition in this case. And that's how it basically works. And important is also this is the partition strategy which is used for Spark for shuffle operations. So it's important to know, even though for shuffle operation, if you get some skew in your hash partitioning, there's something called adaptive query execution, which might help, but rather only reducing the number of partitions and not increasing if needed. Of course, there are also some other features in adaptive query execution, but then we're gonna deep dive into another episode. So if you are unlucky, the hashes of the columns, especially if you don't have a lot of distinct values in each column, might be all 0. Let's assume we have numbers which are all divisible by 5, then it's gonna be 0, like worst case scenario. And this happens especially if you have a low distinct value range. An increase of number of rows will not help if still only 5 distinct values are there. The hash depends only on the column value itself. So that's how we cannot mitigate it. We can only mitigate it by adjusting a little bit the number of partitions. Because if you divide 1000 suddenly, but if you create the modulo via 7 with 1000, suddenly you're gonna have errors and it will not be always 0, as an example. So let's have a look again into a data example. So here we pretty much have the same data set as before, 20 rows, 4 partitions initially. So we can also see it's perfectly distributed. And now we are basically repartition based on ID last. So what you would assume, so we have 5 target partitions, you would assume that you're gonna have one partition with 0, 1, one partition with 2, 3, one partition with 4, 5, or it can also be 4 and 7, but that you would have a distributed data set. But what you can see, no, this is actually not the case. So we have a 1, 3, 4, and 0. So, and the reason for that is apparently, so if you're gonna take a look now into the partition ID which has been assigned, so 0 has been hashed with a modulo 0. I know this was a wrong one, so ID last we have to look. 1 and 2 are 4, 5 are 4, so apparently quite a lot of values are 4. Also here we have a 4, and then of course you can also see the next 0 is again a 0, the 1 and 2 is a 4, etc. And yeah, in this case we were just unlucky. Okay, a lot of string values, like string number values, because ID last is a string, as we mentioned before, generated a hash value which was dividable by 5. And even if I tried to show you here like how it really works. I used a hash value from Spark. Apparently, it's not exactly the hash value which repartitioning used. I also couldn't figure out why, but basically the hash function from Spark returns you an integer value. So you can see here we have an integer value, and what we are doing, so basically here hash first of all ID last. So that's basically what repartitioning's just doing. It just applies this momo hash value, and then an integer value is coming out, and then we are creating a modulo 5. And as I had here some negative values, I just took also the absolute value of it. So if you want target partitions 10, we're gonna do modulo 10. And also here you can see, okay, there is some skew. So also here you find the fours quite often, but I think one of the numbers had a different frequency that than in our a real case. So let's see. Okay. So you can see here the with this hash partitioning, you get the 12 quite often. And just to showcase what we had before, so let's take also like 20,000. Okay, I was just surprised that it works out, but this was the wrong row. So you can see here we didn't have any difference. It's exactly the same result. But if I would now repartition, let's say by 6, you see the distribution looks different, but still we haven't resolved the problem. So what we could do is, for instance, we gonna repartition by this column where we had a little bit, where we have a little bit more distribution and more distinct values, even though now we might have not a lot of duplicates. So here we repartition by 6, and now we have the value. So you see that more distinct values, as we have in the column ID first 2, so those are the first ID columns which we have, helps to get a better distribution here. All right, let's come to our next one. So repartition by range. So we also have the same scenarios with hash partitioning. So we want to repartition based on a column. And just to show you shortly the function, it looks like that. So it's called repartition by range. And we have number of partitions which you can define, and also columns. And what you already guess, if it's called repartition by range, you want to repartition based on some range. So basically what the function is doing, it looks in a column, and based on sampling, it identifies ranges of data. So for instance, we have 20 rows, and then we have a range from 0 to 20. So the ID column is a good example, and then it divides it basically into your target partitions, for instance 5. And I mean, you should usually use it for continuous values. That's where it basically makes sense. So also here, if no number of partitions defined, the Spark SQL shuffle partitions is taken, which is defaulting to 200. And how you can screw it up is basically by not using the by using discrete values, and also use a column where some values repeat more often than others. So basically, somehow a skewed data set based on this column. And let's have a look on the same data set as before. So here we can see again we have 25% repartitioned data. So, and you remember that before, let me scroll shortly up. So before we repartitioned based on that. So, and we saw that we have some skew. Now, basically, we're doing the same thing, just with partition by range. And even if it's now a string value, so ID would be a better one, you can see, okay, in this case, we really managed to repartition it as we expected. Because even if it's a string value, you have some kind of continuity. So you can also do it with ID. Yeah. But how to screw it up? I mean, you guessed it already. Here you can see an example where we have quite a lot of ones. And if we would now do repartition based on ID first, let's see if this is indeed the case, you basically screw it up. So in this case, you have like a highly undistributed data set, and that's something you wouldn't like. So based on the name, you guessed it, you should have something which is some continuity. Repetitions are allowed as we had it here in ID last. It takes like the range 0 to 10, and then we have just a repetition of it. And we can also see it here. So you can see the partition before, and then we can see the partition afterwards. And you can see 0, 1 from ID last is basically assigned to 0, then 2 and 3 is assigned to 1, and then when the values repeat again, it's assigned to 0, those two values up to 1 assigned, and so on. And that's pretty much it. So as a summary, when you should take what and what's important. So round robin shuffling if you really want equal partition size and you don't really want to depend on column grouping. If your data set is big enough, also depending on the number of partitions you want to achieve, you will also not really have a skewing on partitions. So hash partitioning. So first of all the shuffle operations in Spark are using hash partitioning in the background. And otherwise you're using it if you want to repartition based on a column. Take care that you don't have a very small number of distinct values, because there can be happening some even worse skew due to repeated number of modular values. So if you have a hash which is divisible by the same number, you might end up in the same partitions. So changing a little bit the number of partitions might help, but of course, if you have 4 cores, you want a 4 or an 8, and then you might still have the same issue. But that's something just to be aware. There are also other strategies otherwise to deal with it. And the last thing is, as already we just had it at the end, range partitioning. Use it for continuous increasing columns where you also want to do a partitioning. based on columns, so that you get like a more distributed value, as we did with ID last. Hash partitioning didn't perform well, but range partitioning performed really well. And with that, thanks a lot for today's sessions, for listening. As always, please subscribe down in the channel. More videos coming soon. And you're gonna find also the script. You play around by yourself a little bit on my GitHub. And the link gonna be found also below. See you soon. Ciao, ciao.